The idea of linear approximation is one of the most important ideas of calculus, and it's really pretty simple. I'm going to illustrate it just with an example. So let's imagine that you wanted to approximate the square root of 28. Now without calculus, you might say, well, 5 squared is 25, and 6 squared is 36. So the square root of 28 should be somewhere between 5 and 6. So how can we use calculate to make an even better guess? Well, the idea is to use the tangent line to a curve. So let's take the graph of y equals the square root of x. Here at x equals 25, we get a point up here which is at a y value of 5. And we've seen that whenever you have a graph like this and you zoom in at a point, it starts to look like a line. And if you plot that line, you get a tangent line, a line that typically looks like it skims the curve at that one point. So first, let's talk in detail about how you find the equation of that tangent line. To write the equation of any line, you need its slope and one point on it. And we already have a point, which is the point 25, 5. And we know that the slope is given by the derivative, evaluated at x equals 25. Well, if y is equal to the square root of x, or in other words, x to the 1/2, then the derivative is 1/2 of x to the negative 1/2, which you can write nicely as 1 over 2 root x. And so if I plug in x equals 25, I get 1 over 2 times the square root of 25, and that's just 1/10. So that's my slope. And then in general, if you have a slope of m, and you have the point, say, AB on your line, then the equation of that line can be written as y is equal to m times x minus a plus b. Notice this looks a lot like the point-intercept form that you may remember, y equals mx plus b. The difference is that the point, if it's not a y-intercept on the y-axis, but is somewhere over here at a different x value, well, you just need an extra sort of piece here, an extra minus a. So in our case, that line looks like y equals 1/10 of the quantity x minus 25, all plus 5. And you could simplify that, but maybe let's not. Let's just keep it like that. So there's my tangent line. Now the point is that if I want the square root of 28, the point that I really want is this point here on the curve y equals the square root of x, that I would get by plugging 28 into that function. But that's kind of hard, and we see that this tangent line, you can see just a little bit of a difference between the line and the curve at this x value, but not too much of a difference. And so the idea then is that we're going to approximate the square root of 28 by plugging 28 into the tangent line instead of into the actual function. Okay, so the square root of 28 is approximately equal to what we get by plugging x equals 28 into the tangent line. So in other words, I want 1/10 of 28 minus 25 plus 5. Well, 28 minus 25 is 3, and 3/10 is just 0.3. So our approximation becomes 5.3. And just for the heck of it, you might want to check the square root of 28 out on a calculator to see how close that is. It turns out that the actual value for the square root of 28, well, to the nearest hundredth, it's 5.29.